I am Anil Kumar. Welcome to my series on transformation of functions. This video is for my student Arjun, and I hope many of you will benefit from what we are talking about, the transformation of functions. So we'll begin with the very basic concepts, right? So the heading here is basic concepts of transformation of functions. So whenever we talk about functions, we relate one with the other. As you can see, I've written y equals to f of x and g of x as a f of something. So g of x is related with function f of x. The only thing is there has been some transformation, right? When we move from the y f of x to g of x, right? So there is some transformation. We'll try to understand what this transformation is. Basically, we'll try to understand the meaning of these letters A, K, P, and Q. In your books, P and Q, you may be seeing this as D and C or H or K, right? But the meaning-wise is exactly same. Remember one thing, that outside letters, which are A and Q, represent vertical transformations, and the inside terms, which is K and P, represents horizontal transformations. We'll take them one by one and then try to understand their meaning. So let's begin with A first, right? So the letter A means what? Now A could mean many things. It's very specifically three things. One, A could mean vertical stretch. Vertical compression, or reflection on y-axis. Everything vertical. Do you see that? So A could mean either of these three things. It means vertical stretch by a factor of something if the value of A is greater than 1. So we normally write absolute value of A, right? So it could be even minus 5, which is greater than 1, the magnitude, right? So that means the magnitude of A is greater than 1, it means vertical stretch. If the magnitude of A is less than 1, that means between 0 to 1, it means vertical compression, and reflection is when the value of A is negative, that means less than 0. Does make sense to you? That is the meaning of A, right? So this is all vertical, as you can see, right? Now let's move inside and talk about the term K, which is inside the bracket, right? Remember, the coefficient of X has been factored and K has been taken outside. This is important to check. So let's talk about K itself. K represents horizontal compression, horizontal stretch, or horizontal reflection. So I'll write this here as horizontal. Instead of stretch first, I'm writing compression. Inside, things are reversed. Horizontal stretch and reflection on which axis? Y-axis. That is horizontal in nature, correct? So when will it have horizontal compression? It will have horizontal compression when the value of K, the absolute value of K, is greater than 1. However, if the absolute value of K is less than 1, then the graph stretches horizontally, right? And when there is a reflection on the y-axis, that time K should have been negative. So that is the effect. Now whenever we are seeing this effect, and whatever I am writing, we are writing in terms of what happens to the graph of g of x, right? So that is, we are comparing graph or even the points on f of x with that of g of x. That is the transformation which we are talking about, okay? Now let's move in and take another point, which is P. So the parameter P will mean that the graph has moved P units right or left. It moves right, it moves P units right when P is positive, that means greater than 0, and it moves P units left when the value of P is less than 0 or negative, right? Now let's talk about the last term, the parameter Q. Q represents vertical translation, right? So Q units up or Q units down. Q units up when Q is positive and Q units down when Q is negative. Does make sense? Correct? So these are some basics which you should know about. We'll take up some examples. Now, we'll also see how to describe the transformation. So let me take two examples here. Okay. I'll take slightly complicated examples and then we'll have simpler ones as a test for you. So let me write down a function which is g of x equals to minus 2 f of 3 x plus 1 plus 5. Now, how are you going to describe this transformation based on what you've learned? So what we should do here is that we should go from left to right. That is kind of very important. You should go from left to right to describe. Okay. So the leftmost thing is minus. What will this minus represent? A is negative, means reflection on y-axis. So the graph is reflected on y-axis. This is the first thing, correct? Then 2 means vertical, I'm writing V for vertical, stretch by a factor of 2. That means everything gets multiplied by 2, right? I didn't mention by factor of in this side, right? I was describing. But when you are given an equation, you have to be more specific. So you have to mention the word vertical stretch by a factor of 2. That means multiply by 2. If you don't mention by a factor of 2, you might lose 0.5 marks. Okay, let's move inside. We have 3, which is k. 3 is more than 1. That means what? That means horizontal. More than 1, reverse. It is compression. Do you understand? By a factor of what? You have to make things smaller. So by a factor of 1 over 3. So normally we write by a factor of 1 over k here, right? And here we are writing by a factor of a. So 3 means horizontally compressed by a factor of 1 over 3. Is that clear to you? Perfect. And plus 1. Now remember, here it was minus. That means P has become negative to make that positive. So that 1 represents 1 unit left. And we write translate 1 unit left. You can add the word horizontally. And 5 units up. Say translate vertically, you could write, right? 5 units up. So a few things I missed here. For example, translate, I could have written horizontally 1 unit left. Better, right? So be careful. You may miss few critical words, then you might lose some marks. Now the critical words are by a factor of. Whenever you're describing A or K, because that is multiplication. Q and P is addition and subtraction. Think like this, right? So we are doing multiplication first and then addition, subtraction. When you describe, you could combine these two and those three. You could do that. Perfect. I hope you've understood how to describe a function's transformation, right? Now there's one more thing apart from just this description, and that is to understand what happens to our coordinate points. So if on the function we have a point x and y, then on g of x we will have transformed x and transformed y. How do I get those points? That is very important to understand. So now I'm going to give you a formula to find these transformed points. Correct? So this is important. How to find, we say image coordinates. Right? So that is what. Now, if you are given the coordinate of a point A as x and y, and let us say that is the equation you are going to work, then A dash is your image coordinate, right? So how will your image coordinate be? In general, let me use this general equation and give you the one. Horizontally, it is always divided by a factor of k, so the value of x will be divided by k, and then you are moving it to the right, correct? So that means you are adding p, moving to right, so plus p, comma. Y coordinates are multiplied by a, so you write a times y, and then you'll say plus q because you're moving this up when q is positive. So that becomes a general formula for transformation of points. You get an idea. Given this formula, can you write down the transformation for this transformed function? Let this be your exercise. Okay? So think about it and then write it down. Okay? Take your time. Here is how we'll get the new points. If my original points are x and y, then the new points are going to be, the x points will be divided by 3, that is x over 3. This is minus 1, right? We do reverse inside. And the y points will be multiplied by minus 2, since there is a reflection to y point, and then you add 5. Do you see that? So that is how, after explaining all this, you can actually transform the points using this particular equation. Perfect. So I hope with this you get all the concepts required for transformation of functions. We could actually transform each and every point and then the graph also. Perfect. So based on this, let us have 6 or 7 questions now. So that will be a kind of a drill just to ensure that you have understood all the concepts. So let's take question number 1 now. We're talking about the transformation of points. Based on that, we have our question number 1. Given point 1 minus 3 is on the graph of y equals to f of x on this graph. Write the corresponding point on the graph of y equals to f of x plus 3, y equals to f of x plus 3, y equals to minus f of minus x, y equals to f inverse of x. Now inverse, we have to switch x and y. And y equals to f of minus x minus 4 minus 1, and y equals to 1 minus f of 2x minus 2. You can now pause the video, answer the question, and then look into my suggestions. Now, we'll do it in 2 steps. In first step, let us assume that we have any general point x and y, and we want to know how should our xt and yt, the transform point, be, right? So we'll write that part, right? So we'll only write xt, yt for each. And then we know that xy is 1 minus 3, right? So then we'll make another column here. And we know that the xy point is 1 minus 3. And what should it be on this particular graph? Is that okay? So that is what we are going to do. In the first case, the f of x plus 3 means the graph moves 3 units up. There is no other transformation. It is vertically 3 units up. Only y value will change. So in this case, the point should be original point x and the y value should be added by 3. You get the idea, right? So the transform point is x, y plus 3. In the second case, when we say f of x plus 3, now in this case, it is inside the bracket. Have a look. Inside the bracket. So p is negative 3 now. Do you see that? P is negative 3. So in this particular case, the x value is going to change, y remains same because outside there is nothing happening, right? So the x value becomes x minus 3, y remains as y. So we are changing x, y to these new points. These are the transformed points. Minus f of minus x means both x and y has been reflected, one on the x-axis and the y-axis, so both become negative. So we get minus x minus y as our answer. Inverse means you're just going to swap, right? So xy will swap to yx. Now in this particular case, this is kind of tricky. You should be rewriting this function and then finding your answer. So let me rewrite and show you what I mean. It should be written as y equals to f of square brackets. This minus I have to factor out. So when I factor this minus, I get x plus 4. Do you see that? And we have x minus 1. Now that really means that there is a reflection on the y-axis, right? So x becomes negative x. And then this plus 4 means negative 4. So in this particular case, the x coordinate becomes negative of x. You have to multiply by this first, and then you have to take away 4. That is what is going to happen for the x value. As far as the y value is concerned, 1 negative means you will decrease the y value by 1. Is that clear to you? Now let's look into this last one here, which is very similar to the previous one. Can you do this one? Pause the video and try it out. Okay. Here is what I will do with this function. I'll rewrite this, right? So what we have is this is plus 1. I'll write plus 1 separately on the right side. Here we have minus, so I'll begin with minus f, and then I'll also factor 2. So when you factor 2, you get x minus 1. Square bracket close. Now, do you see the importance of square brackets which I began with in the first place? That is very important. You have to always factor the coefficient of x. Otherwise, you will think that it is 2 units right. But no, it is only 1 unit right. You have to factor 2. In this case, the x and y coordinate should be what? The x value divide by 2, right? Yes. And that means moving 1 unit to the right as far as y value is concerned, reflect it and then add 1. So that becomes your new point. Perfect. Now with these transformations explained, I would like you to fill this up. What happens to a point 1 minus 3 on f of x? Let's write down all our results. So in the first case, plus 3 means vertically it is moving 3 units up. The x value remains as 1. The y value becomes minus 3 plus 1. Minus 3 plus 3, right? 3 units up. So that means the point will be 1, 0. Do you get it? It moves up by 3 units. In this case, the x value changes, x minus 3. So we'll do 1 minus 3 and write the y value as such, which is minus 3. So the point will be at minus 2, minus 3. Is that clear? So you have to do this work to get your result. In this case, you have to just switch the signs, right? So the sign changes, becomes minus 1, that becomes plus 3. In this case, you have to swap. You get minus 3 and 1 for your inverse function. Now here, it requires some more work. So let's do it in 2 steps. Step 1, minus of x minus 4. Minus of x is 1, placed 1 here. We get minus 1 minus 4 and y value is minus 3. So we'll write minus 3 minus 1, correct? So that is equal to minus 5 minus 4. So that is your answer. Now can you pause the video and write down the answer for the last one? Okay, here is it. Divide the x value by 2 and then add 1. X value is half. Add 1. So 1 divided by 2 plus 1, as far as the y value is concerned, make it negative first. Negative 3 is your y value, so make it negative. So negative of negative 3, and then add 1. So what do you get? You get 1.5 or 3 by 2, and this value is plus 1, right? Okay. So when you add 1 to 3, it becomes 4. So that becomes your new point. Does it make sense to you? So what you learned here basically is, if you are given like this, coefficient of x should be factored and rewritten. Use square brackets to avoid confusion. Here also, minus was factored, rewritten, and then you get your transform points. Is that clear? Let's take another question which is very similar, and I hope this time you'll get them all right. Question number 2. So let me write question number 2 here, right? So question number 2. The function f of x is 1-to-1 function. The point 2 minus 6 is on f of x. For each transformation given, describe the transformation in words and then determine the new point. So you should write the transformation in words. I'll describe you. I may not write the complete thing here, right? And I'll provide you with the solution, which is what happens to our original point xy is given to us as 2 minus 6, which is on f of x, right? So this is on f of x. What happens when the transformation takes place? The very first one, if you can see here, g of x is f of x minus 5. What do that mean? Minus 5 outside means it is translated 5 units down. So when you do 5 units down, the y value changes, x value will not change, right? So basically the transformation is x value remains same, but the y value decreases by 5. In our case, 2 and minus 6, we'll write this as 2, the x value. Y value will decrease by minus 5, and so we'll make it minus 11. Is that clear to you? So further it goes down from minus 6. Next one here. X plus 4 is within the brackets. That means horizontally, right? So here, 4 units left or right? Tell me. It goes left. Normally in the formula it is minus, right? So minus and minus makes it positive. 4 units left. Left means you have to decrease the x value by 4. However, the y value remains same. And therefore, the new transform point will be 2 minus 4, which is minus 2, and the y value will remain as minus 6. Correct? Next one, f of x minus 1 plus 3. So it's kind of combination of previous two. Minus 1 means you translate 1 unit right and 3 up. Do you see that? Plus 3, 3 up. So that means as far as the x value is concerned, you are going to add 1 to the x value and 3 to y value. And so when you add 1 to 2, you get 3. And when you add 3 to minus 6, you get minus 3. That becomes your transform point on this function. Is that clear to you? Now, let's get into some multiplication. 3 f of x plus 2. Now there is a multiplication factor by 3. It is a vertical stretch. So I'm writing vertical stretch by factor of 3. That is the first thing. And then 2 units up. 2 units up, right? So these are the transformations which are taking place. They are affecting only the y value. Nothing happens to x value. X remains same. Y value gets multiplied by 3 and then you add 2. So what we get here, same x value as 2, the y value gets multiplied by 3, that means minus 18, and then you add 2, it becomes lesser minus by 2. So minus 16. Perfect. Now in this case, minus x means reflection on y-axis. So this is reflection on y-axis. That really means that the x value becomes negative inside horizontal, y value remains same. So instead of 2 minus 6, we get minus 2 minus 6. G. G of x, sixth is f inverse. So when you do inverse, you swap, right? So this is inverse. That means the reflection on y equals to x line, right? So that is your inverse function, right? So let me write inverse here. So basically you swap. So what you get here is minus 6, 2. Perfect. The last two, I think we'll do it on a fresh page. It requires more description, right? These two. So let's do it on a fresh page. So let's continue with our question. And here are the last two parts of question number 2, right? So let me rewrite here question number 2. So what we are given here is the point 2 minus 6. So 2 minus 6 is given to us. We need to find the new point after transformation. We normally call it image, right? So we want to see what is the image. The transformations are explained. H of x is 1/3 of f of 2 of x. That means what? So let's try to describe this. 1/3 here means that it has been vertically compressed by a factor of 1/3. So let's write down. So it is vertically compressed by a factor of 1/3. And then what does that 2 means, which is inside? It means horizontally compressed by factor of half. Do you see that? So both are compressions, right? So the new point will be kind of like what? So basically the y value, if we have x and y, right? In that case, the x value will become half of the original x value. The y value become 1/3 of original y value. So this point, this is going to be the result, right? So we'll do half of 2, which is 1, and 1/3 of minus 6, which is minus 3. So that will be your new point. Is that clear to you? Take your time to understand this. Very critical and important, right? And now do 7th question yourself. Okay, here is the key. The function g of x should be rewritten because we have coefficient of x as 2. I have to factor this out as 2. Then within the bracket, I get x minus 2. Does it make sense to you? That is important. If you do not do this, then you're going to get a wrong result. You'll think 4 units moving right. No, it is 2 units moving right. So let's describe it now. So here, first transformation, move left to right, is horizontally compressed by a factor of half. First thing. Second, that 2 moves 2 units, translate right. 8 is 8 units up, vertically up translation, right? So you could use the word translate in between. Now in this case, what is the kind of coordinate change? So the x value, as you can see, will be divided by 2. And then we are going to add 2. As far as the y value is concerned, we are going to add 8. Since the graph has moved 8 units up. So what the result will be? Dividing 2 by 2 is 1. 1 plus 2 is 3. So I get 3 here. As far as the y value is concerned, when you add 8 to minus 6, you get plus 2. So that is your new coordinate. Perfect. So that is how you're going to answer this question. I hope it's absolutely clear. Now we are going to take some graphs and we'll take a small break in between. Enjoy the beautiful weather here and some wildlife in our city of Toronto. And then we'll take up question number 3. I hope you enjoyed the break, the beautiful wildlife here in the city. Now let's continue with the questions. Question number 3 is very interesting. This time we are going to read the values from the graph and then apply the transformation. Question number 3. Given the graph of f of x, that is the graph of f of x. For each transformation, describe the transformation in words and then graph the transformation, right? So that's the question for you. Now, whenever we are talking about graphs, it's good point to always find the coordinate points, right? So first step, let me label them. So I'm going to label these points as A, B, C, D, and E. So let's say this is A for me, that is B. Here we have C, then we have D, and is going to, let's say, E, right? So we'll have all these points. So let's read the coordinates of each point first. So A. So A is -4, -5. This graph is slightly smaller. You might not be seeing it properly, but these are the points. Now I think it's clear, right? A is -4, -5, and B is -2, -2. C is 0, 1. D is actually 3 and 3. And E is 6 and 5. Okay, so these are the points. In the first function, g of x is f of x minus 2. It really means that only the y value changes, nothing happens to the x. The graph comes down by 2 units, right? So I can write down the new points as a dash, right? So we have this point a dash, which will be 2 less y value. So x value will be -4 and y will be 5 minus 2. So I'll take away 2 from the y values to write my image points, right? Keeping the x points same. Does it make sense to you? So C dash means the transformed points. Is it okay? So we have -1 and D. We have 3 minus 2 is 1. And as far as E is concerned, it is 6. 5 minus 2 is 3. We get these points. Now when you have to graph these points, basically the graph comes down by 2 units. So every point comes down by 2 units, right? So this point comes down by 2 units, 2 units. You see this was at 3, so it will go at 1, and this was at 5, so it will move at 3. So that is your new graph. Got it? So we'll just join these points and sketch our graph. Do you get it? It will start from here. So that is how you have to do the exercise, right? Now let's look into the second point. The second point here is g of x, f of x plus 1. Only the x value changes, y remains same. The graph moves 1 unit left. So the points here are, now I'm writing the points, not a dash, b dash. So 1 left means -4 becomes -5. 5 for y remains same, right? And the next point here will be -3 minus 2. Then for C, it is going to be -1, 1. And then for D, it is going to be 1 less than 2, 3, which is 2 and 3. And for E, it is going to be 5, 5. You get the idea. On a graph, without even looking at the points, you could move each unit 1 unit left. Do you see that 1 unit left moving, right? So when you get 1 unit left, just join them. Just join them. So we have another graph here which represents the second one. Does it make sense? It continues forever. So that is how you are going to draw each and every graph. Perfect. Next is x minus 2. X minus 2 means you are moving the graph 2 units to the right. So I'm describing here. So that means translate 2 units right. Since the question says you have to explain in words and then do it, I'm trying to do both, kind of, give you an explanation, not writing, but you have to write. Translate 2 units right, the original graph. So what I'm going to do here is just move this unit 2 units to the right. So this point moves 2 units right, this moves 2 units right, 2 units right, 2 units right. You see that. So what you get here is a new graph kind of like this, and that becomes 2 units right. I hope you are getting all this, right? Next graph here is to reflect on the, what is this reflection? It means reflect on x-axis. So all the y coordinates are going to change. So the points will be, the original points, x value remains same, y becomes negative of whatever it was. Do you see that? So the new points will be kind of like this. Perfect. So what do you see? The reflection of this on the x-axis. So I like you to plot these points and then sketch your graph. Got it? That is what you're going to do. The last one here means what? It means that minus of x inside means reflection on. So let me write down here description. First is reflection on y-axis. This is because of this point. And then what are we going to do? Translate 1 unit up, 1 unit up. So the x values become negative and y values you have to add 1 to get the new points. So once you get the new points, you can plot them on the graph. Let me write down the new points for you. All the x values I'm going to flip with the sign. So the first point will be plus 4. The y values I'm going to add 1. So that becomes 6. So for b, it becomes, instead of negative 2, positive 2. And when you add 1 to minus 1, 2, you get minus 1. Now c, reflection to 0 means 0. And y becomes 1 plus 1, which is 2. Then d, minus 3. And add 1 to 3 to get 4. As far as e is concerned, minus 6, add 1 to 5 to get 6. So those are your new points. I'd like you to plot those new points on your graph. Take a new graph, right? And then do it. I hope that makes sense. Now we'll do 2 other questions from question number 3, which are slightly more complicated, and we'll try to sketch them, okay? Here's continuation to our question number 3. We are still working with the same points. Let me rewrite the points. Point A is for us minus 4, 5. Point B is minus 2, minus 2. Point C is 0, 1. Point D is 3, 3. And point E is 6, 5. Right? So these are the points marked. Now here, the 6th one is f of minus x plus 1. It means what? So minus means reflection on y-axis. And 1 means 1 unit up. We did it, right? 1 up. So the new points, the x values will become negative, or whatever they are. The y value increase by 1, right? So the new points in this case will be, so I'll change this to positive 4 and increase the y value by 1, so 4, 6, right? So this will become 2, and when you add, you get minus 1. Here, 0 remains 0. When you add, you get 2. Here, minus 3, and then when you add 1, you get 4. In this case, minus 6, and when you add 1, it becomes 6. So these are the new points. We'll try to plot these points now. So we'll begin with 4, 6. So at 4 we have a point which is 6 for us. 2 minus 1. So 2 minus 1 is your new point. 0, 2. So at 0 we have the same point here as 2. Minus 3, 4. So minus 3, and then 4, it goes up to this point. Okay. And minus 6, 6. So minus 6 is right there, and 6 is somewhere up, right? So this graph is not so clear anyway. We'll just estimate and put it here. Correct? So these are our new points. So first is, we have reflected this, so the arrow goes towards that side. Do you see that part? So arrow moves towards this side. And the whole graph moves 1 unit up. So this moved 1 unit up. Do you see that part? So this graph moved 1 unit up and also reflected, right? This is wrong. The first point is, actually this is -4 -5. That is why the mistake is there, right? So this point here is -4 -5. And so when I change -4, it becomes 4. And when I add here, I get +4. That is why this point is wrong. Correct. So the last point is 4, 4, not that what is written there, right? So it is right there. That makes sense. So we are going to now join this with these points, and that is what you get. So you can see clearly, this graph has been reflected and then moved 1 unit up, right? Do you see that part? So that is how you're going to do it. Now let's look into the last question. What does this minus outside means? It means reflection on x-axis. And this -1 means moving 1 unit right. So 1 right and 3 up. Do you see that? So that means that the new coordinates, the y values will be negative and +3. The x coordinates will be add 1. So the transformation is x plus 1 and the y value become negative y plus 3. Right? So let's do this and write down the result. So the x values I'm going to add 1. So -4 becomes -3. The y values, I'll make negative of -5, which is +5, and 3 will give me 8. Here, if I add 1, I get -1, and negative of this is 2. 2 plus 3 is 5. Now here, the next point, I have to add 1, and the y point will be -1 plus 3, which is 2. 3, 3. So adding 1 to 3 makes it 4, and taking away, 3 becomes negative, and then when you add becomes 0. 6 and 5. So 6 plus 1 becomes 7. 5 minus 5 plus 3 is -2. That is your new point. Now we'll plot these points and then sketch its graph. Correct? So -3, 8. So we get -3 and +8, which is kind of here. Then -1, 5, -1 and 5. Okay. Then we have 1 and 2. Add 1, we have the value 2. 4 and 0. So 4 and 0. And then we have 7 and -2. So kind of coming downwards here. Right? So the graph here is this. Do you see that? So as you can see, it has been reflected on the x-axis and then moved 3 units up. So this portion here has been reflected, right, and moved 3 units up, right? So that is how it is going to be. Perfect. So that is how you're going to do these transformations. I hope the concept is clear. Now that arrow is kind of very important to understand. The domain here is from -4 to infinity, right? So when you do reflection on the x-axis, then the domain becomes towards the -infinity side. You set from 4 to -infinity. So in this case, the domain is from that x belongs to real numbers, where x is less than equal to this point, which is 4 for you, right? In this case, the domain is, we are moving right side of this. Do you see that portion, right? So it is from the lowest value, in this case is -3. So x is greater than equal to -3. That is the domain. So that is kind of important. So I like you to write domain and range for the given function, right? Domain and range for the transform function. Okay, so I've written the domain, you have the graph, write the domain range also. Perfect. Okay, let's move on and take the last question from this exercise. We're almost at the end. Here is the last question, question number 4. A linear function has the equation y equals to 2x plus 5. Write an equation for the line found by reflecting the line on the y-axis. Right? So let's try to understand. So basically we have our graph and we are reflecting on the y-axis. That is like moving like this. That means we are moving horizontally, right? So the equation should be f of minus x. You get an idea, right? The next one here is write an equation for the line found by reflecting the line on the x-axis. So this time reflecting on the x-axis means whatever the graph is, which is the straight line, you know, kind of like this, it has to be reflected on the x-axis. That means it is vertical. So the equation should be minus of f of x. The last question here is, the linear function is reflected through the line y equals to x. What is the equation of new line? So basically in this case, we are doing inverse of a function, right? So what are we doing this time? We have a line y equals to x. So we are reflecting our line, which is, let me sketch the line now. 2x plus 5 will be something like this. We are reflecting this on that line. What do you expect? Well, you expect it to be, this point will come here, this point will remain. So you expect it to be like this. So if this is your function f of x, this is inverse of the function. Do you see that? Now can you write down the equations? Pause the video, write the equations, and then check with my solutions. Okay? Here is my solution. So the very first one, I'm just doing negative of this, right? So we get g of x as equal to negative of 2, I'm sorry, we have to make only x negative, right? So g of x equals to 2 times negative of x plus 5. So the x becomes negative. So we get our answer as minus 2x plus 5. Is it okay? So that is for A. In the second case, we are doing negative of everything when we flip it over, right? So in this case, g of x will be equal to negative of 2x plus 5, which should be equal to negative 2x negative 5. The last case here, you have to swap, right? So you could do it like this. You are given the equation, which is y equals to 2x plus 5, right? You swap. So you get x equals to 2y plus 5. Then you solve for y. You get x minus 5 equals to 2y, or y equals to half x minus 5 by 2. Correct? So your equation now is g of x equals to half of x minus 5 by 2. That is the inverse, right? You could do it the other way. That is, read it in the reverse order. Subtract 5, divide by 2. You could do that, right? Which is to say, g of x equals to subtract 5, divide by 2. One and the same thing. X divided by 2 minus 5 by 2. You get that graph. Perfect. So that is how you could get all the three equations after the lines have been transformed. So we have understood how the reflection takes place for a straight line. I hope that makes sense. I'll provide you with few links which will give you transformation of functions with additional practice questions. Try to do them before your test, and that should really help you. I hope this journey was beautiful. You enjoyed it. Feel free to write your comment, share your views. If you like and subscribe my videos, that would be great. Share my videos with your friends. Thank you, and all the best.